Have you ever pondered the significance of water diversion projects and the engineering marvels behind them? These projects are not merely about moving water from one place to another. They are about harnessing the power of human ingenuity to shape the world around us. Consider the role these projects play in our society. They provide life-sustaining water to arid regions, power our cities, and even help grow our food. Yet, they are not without controversy. The balance between human needs and environmental impact is a delicate one. Every dam, every canal, every pipeline is a testament to our ability to overcome challenges. But they also serve as a stark reminder of the consequences of our actions. The landscapes we alter, the habitats we disrupt, and the communities we displace are all part of the cost. Embark on a journey through time as we explore the engineering feats behind these projects. Travel back to 312 BC to the era of the Roman Empire, where the first known water diversion project was born. Welcome to the world of Roman aqueducts, the engineering marvels that revolutionized the transportation of water. Imagine, if you will, ancient Rome, a bustling city with burgeoning population and increasing needs. The Romans, with their advanced civilization, realized the importance of a constant and clean water supply to sustain their growing population, public baths, fountains, and agriculture. But Rome's local water sources were insufficient and often polluted. The solution? The Roman aqueducts. The construction of these aqueducts was a monumental task, requiring exceptional planning, design, and engineering skills. The Romans surveyed the landscape, calculated gradients, and used their knowledge of hydraulics to create a system that could move water over vast distances, solely driven by the force of gravity. They built these aqueducts with a slight downward slope, so subtle that it's barely perceptible to the naked eye, but just enough to ensure a constant flow of water. The aqueducts were primarily constructed from concrete, a material the Romans perfected. They used arches, another Roman innovation, to build the aqueducts high above the ground, allowing the water to flow across valleys and uneven terrain. This elevated design also kept the water clean and safe from ground-level contaminants. These structures were not just functional, but aesthetically pleasing too. The towering arches of the aqueducts became iconic symbols of Roman engineering prowess, a testament to their ability to bend the natural world to their will. But the aqueducts were more than just a means to transport water. They were a reflection of the Romans' understanding of public health, of their commitment to the welfare of their citizens, and their foresight in planning for the future. They understood that a reliable, clean water supply was essential for a thriving civilization. The Roman aqueducts were the beginning of a new era in engineering, setting the stage for future water diversion projects. Their legacy lives on, not only in the ruins that still stand today, but in the principles of engineering, public health, and urban planning that they pioneered. Fast forward to the 20th century, to the construction of the Colorado River Aqueduct in the United States. This impressive feat of engineering spans 242 miles, linking the Colorado River to the arid lands of Southern California. But why was such a mammoth undertaking necessary? Southern California was in dire need of a reliable water source to sustain its rapid urban development. The region was growing faster than its local water supplies could support, and the Colorado River was identified as a potential lifeline. However, diverting its waters across the rugged terrain and vast desert was no small task. The construction of the Colorado River Aqueduct posed significant challenges. Workers had to contend with harsh desert conditions, and engineers had to design a system that could traverse mountains and valleys. The aqueduct's construction involved drilling through solid rock to create tunnels, erecting massive pumping plants to lift the water over mountain ranges, and constructing hundreds of miles of canals and pipelines. Despite these challenges, the aqueduct was completed in just 5 years, from 1933 to 1938, largely thanks to the advanced engineering techniques of the time. Remarkably, the aqueduct was designed to rely primarily on gravity to transport water, reducing the need for energy-intensive pumping. The impact of the Colorado River Aqueduct on Southern California has been transformative. It has enabled the growth of major cities like Los Angeles and San Diego, and it continues to supply water to millions of people and acres of farmland. The aqueduct has also sparked important conversations about water rights and sustainable usage, as the Colorado River is a shared resource among several states. The Colorado River Aqueduct is more than just a conduit for water. It is a symbol of the power of human innovation, showing how we can harness nature to meet our needs, even in the face of daunting obstacles. It represents the intersection of necessity, ambition, and ingenuity, and serves as a reminder of the lengths that we will go to secure our future. The Colorado River Aqueduct is a testament to human ingenuity, demonstrating our ability to overcome geographical challenges. Now, let's travel to the east, to the most ambitious water diversion project in history, China's South-North Water Transfer Project. Imagine a project so colossal it requires rerouting three of China's largest rivers. The South-North Water Transfer Project, or SNWTP, is just that. It's a testament to modern engineering, designed to alleviate China's severe water scarcity problem. Spanning a staggering 1,400 miles, that's roughly the distance from Miami to Boston, the SNWTP is divided into three routes: the Eastern, Central, and Western. Each route is an engineering wonder unto itself, involving a complex system of dams, reservoirs, canals, and pumping stations. The challenges faced during its construction were immense. The project had to overcome substantial geographical hurdles, from mountains to deserts. And let's not forget, it had to be executed without disrupting the lives of millions of people and the delicate ecosystems along the routes. But with a workforce that peaked at over 300,000 people and a budget that ran into tens of billions of dollars, China proved that it was up to the task. The eastern and central routes are now operational, delivering billions of cubic meters of water every year from the water-rich south to the parched north. The SNWTP is more than just a water diversion project. It's a symbol of human resilience and ingenuity. It has not only mitigated China's water scarcity issue, but has also spurred economic growth in the northern provinces, proving that the benefits of such a project go beyond the immediate need for water. However, it's also a stark reminder of the global water crisis we face. It underscores the importance of sustainable water management and the need for innovative solutions to ensure water security for future generations. The South-North Water Transfer Project is a marvel of modern engineering, demonstrating our ability to tackle large-scale problems. As we stand on the brink of a new era, what does the future hold for water diversion projects? This question is more pertinent now than ever before, as we grapple with the challenges of a changing climate and a rapidly growing global population. The future of water diversion is a story yet to be fully written, but one thing is certain: it will be shaped by continuous advancements in engineering, coupled with an increasing necessity to balance human needs with environmental sustainability. In the coming years, we can expect to see water diversion projects that are not just bigger, but also smarter. Technology and innovation will play a pivotal role in this evolution. Imagine, for instance, automated systems that manage water flow based on real-time demand and environmental conditions. Or consider the potential of advanced materials, ones capable of reducing leakage and improving the longevity of these megastructures. But it's not only about technological advancements. As we move forward, there's a growing understanding that we must work with nature, not against it. We're beginning to see this reflected in the design and execution of water diversion projects. Future endeavors will likely incorporate elements of green engineering, aiming to minimize environmental impact and create more sustainable water systems. Innovation will also extend beyond the physical structures themselves. The future of water diversion will necessitate new ways of thinking about water management policies, stakeholder engagement, and cross-border cooperation. After all, water knows no boundaries, and our approach to managing it must be equally boundless. But let's not forget, while we strive to quench the thirst of growing cities and irrigate arid lands, we must also ensure that our actions today do not compromise the needs of future generations. It's a delicate balance, one that will require not only engineering prowess but also foresight and wisdom. As we continue to push the boundaries of engineering, we hold the power to shape our future, one drop at a time. The future of water diversion is undeniably exciting, filled with promise and potential. Yet it also holds a profound responsibility, a reminder that every drop counts, and every decision we make today will ripple through time, shaping the world of tomorrow. From the Roman aqueducts to the South-North Water Transfer Project, we've journeyed through centuries of engineering marvels. We've seen how civilizations rose and thrived, harnessing the power of water, bridging over vast distances, and creating life in the most barren lands. These grand projects, born out of human ingenuity and sheer necessity, have shown us the significance of water and its role in shaping our world. We've witnessed the Colorado River Aqueduct, a testament to our capacity to conquer the most challenging terrains. And then, the South-North Water Transfer Project, a modern-day marvel that demonstrates the scale at which we can operate when the need arises. These are not just structures of stone, steel, and concrete. They are symbols of our resilience, our creativity, and our relentless pursuit of progress. As we marvel at these feats of engineering, we are reminded of our ability to innovate, adapt, and overcome. The future of water diversion is in our hands.